In a horse field in Cambridgeshire stand several large concrete pillars. They don't mean much to the untrained eye, but it's amazing that this was the very spot so many came to dream, and where for some, the 1970s dream of ultra-high-speed rail travel burst. To understand this special train, we need to have a look at another UK invention, the hovercraft, and how it works. Put it simply, the hovercraft works by trapping a cushion of air under its skirt, causing the cab above the skirt to lift. Air is only released upon its contact with the ground or water surface, and the craft can be propelled across surfaces by the use of fans with a rudder guiding where the fans blow, providing direction. It's a simple and effective way of transport, especially across terrain that may not be passable by road, boat or rail. It was established that the energy to lift the hovercraft off the ground was relative to the type of terrain it was travelling on. For example, if the train wasn't flat, a marsh, or if the sea had a large swell, then the energy used would be greater as more air escaped the skirt and needed to be replaced in order to keep the craft afloat. While this was not a new discovery, Hovercraft Developments Limited found that compared to a similar sized vehicle that had steel wheels, a rail car for example, the energy used by the hovercraft was a lot lower, especially at high speeds. Excited at the discovery, more research was done, and it was found that if a vehicle can run on a designed track, but it hovered instead of having wheels, it would have the same positive attributes of the hovercraft. Because it was riding on a bed of air, the ride would be smoother. It wouldn't need complex suspension. Unlike wheels, the load would be better spread along the lifting pads, as the lifting pads could run the full length of the train. This had a further benefit as the rail guiding the engine need not be as complex as a track bed, and effectively would be carrying less pressure. The research also uncovered that the new propulsion could solve an existing issue that current trains had if going at high speeds. All train wheels have flanges. The flanges were vital to guide the train along the rails, and the train would simply slide off the track if they didn't have them. Wheel flanges also had their disadvantages. If the train was travelling fast, over 140 miles an hour, the flanges would strike against the side of the rail. This caused resistance, meaning the train would have to exert more energy to combat it. This was called hunting oscillation. In lower speeds, the hunting oscillation wouldn't be a problem, but it was a serious factor to consider when making an express service. If the train was suspended away from the track, simply wasn't a limit to what speed it could do. There was only one real major flaw in this idea, and it was a large one: how to power it. Propellers were out of the question. The researchers had seen what happened with Schneider Zeppelin. A propeller limited the engine to travel one way. The risk to the public standing at station was too great. And unlike the rail Zeppelin, they had no wheels to simply put the brakes on. Hovercrafts reversed the flow of the propeller to stop itself, but it was slow and sometimes unpredictable, and the risk of overshooting or undershooting a platform was simply too high. Unless the researchers at the Hovercraft Development Limited found a suitable power source, the project was simply going nowhere. Luckily, around the same time at Manchester University, a young inventor called Eric Laithwaite was unknowingly developing a solution to the problem. He had developed a new type of motor called a linear induction motor. Basically, an alternating current was passed through a core, creating a magnetic field. It works the same as a standard induction motor, but instead of being round, linear motors are specifically designed to move in a line. The motor was coupled to a simple four-wheel cart, and Eric had built a 20-foot track to show off his invention to British Rail. The new motor would be perfect for the hovercraft idea. The Hovercraft Development Limited research team thought so too, and tried to develop their own. It wasn't as good, but they made do. The new train worked, but when running on test models at high speed, it made the track rattle. The team compensated for this by creating a girder-type track. The top was used for centering the main engine, and the wing-like sides guided the engine, minimising the vibration. Following successful demonstration of his own machine, Eric Laithwaite joined British Rail development team in Derby. This was the exact same team that had helped develop the Pacer. The research team were among the first to recognise the theory of hunting oscillation and made changes to his existing rolling stock to overcome it. Eric was still pushing for the Hovertrain idea, but British Rail overruled him. The cost to change track for high-speed travel, plus the cost to change the existing stock, and the fact that both high-speed and low-speed existing engines could use the same track as opposed to changing the entire network for just one type of train, meant the Hovertrain would have been simply too impractical and costly. British Railways were already feeling the pinch on the purse strings, and while they thanked Eric for their efforts, the Hovertrain would, in their eyes, remain a pipe dream. Another company feeling the pinch of the purse strings was the Hovercraft development team. The funding they had was running low, and they wanted to run fully working full-size prototypes of their Hovertrain. Following an unsuccessful application for a grant from a government, the team dipped into their own running budget to raise the money to build a test track. It was a dangerous gamble. If the project worked, the team would be given funding from investors from the railway industry. If it didn't, they would be shut down for good. Meanwhile, at British Railways development team, Eric was getting frustrated. His research was going nowhere. His ideas were going nowhere. And British Rail simply were not forthcoming with the funding he needed. After hearing of the Hovercraft development team's research, Eric left British Rail and cut all ties with them. He was welcomed to the Hovercraft team with open arms and stayed as a consultant, eventually persuading the government to grant the team £2 million to get the project off the ground. The team had their man, now they just needed it to be a success. At first, the Hovertrain was designed to use two double-sided motors side by side, but this idea was scrapped as it was too dangerous, mostly due to the heat and the magnetic waves it produced. Because of this, the track was redesigned again. They had also designed that the power would be picked up not from any overhead cable, but from vertical wind-shaped surfaces. I can only imagine that this sort of power transfer would have unnerved some people, as the spark from the supply to the engine was easily and spectacularly visible. 4 miles of test track was completed in a few short years, and on the 7th of February 1973, the RTV31 engine took off on its first run, reaching 104 miles an hour. The event was greeted with massive fanfare and publicity, and while the test was hailed a success, the day was marred by mumblings from those in the crowd that the project was doomed to failure and cancellation was imminent. British Rail bit back at the high-speed trains with one of their own. They had just completed the APT, the predecessor of the present-day Intercity 125. British Rail was quick to point out the Hovertrain's faults to the government, and the Hovercraft team were just as eager to give their views on the APT. The government simply couldn't afford to support two high-speed services, but they considered both sides. What would be practical in a city, what would be cost-effective, what infrastructure they could use, what would stay the same, and most importantly, what would be best in giving the most productive service. In the end, the argument was settled by the tracks themselves. Apart from a few areas of improvement, the APT was pretty much ready to go. But the Hovertrains would have meant the entire network would have needed modifications to accommodate for them. It also simply wasn't ready, and wouldn't be ready for a number of years. There was also power concerns, as the engine's drag would have meant more power consumption, so much so that the line would have to have its own power source at multiple points. Within a week of the findings and the recommendations, funding was cut on the Hovertrain and the project ground to a halt. Michael Heseltine, who had originally backed the project, came under fire from government officials, but the government did allow grants for the linear induction motor engines to be researched. Eric was furious the project failed and was openly critical of the government's decision to cancel the project. He still worked on his engine and eventually created a maglev design. He wanted to test the engine on existing Hovertrain's track, but he was denied. He did get one success. His engine was used as the basis for the maglev train on the Birmingham maglev train that ran from 1984 to 1995. But what of the train and the track? The RTV31 sat outside Cranfield University as a static model. The train was not in the greatest shape when it was taken to Rail World in 1996. The engine was restored back to its original state and was set up as a static display outside its main buildings. Rail World was a mix of a railway museum and a nature reserve, and the RTV31 sits proudly at the entrance on a piece of its own track. As you walk around where the track once stood, you can still find remnants of the activity, such as a power station located nearby labelled Hovercraft, and of course the concrete pillars that once held the track aloft. Luckily, there is an organisation keeping the memory of the Hovertrain alive. The Hovercraft Museum still today carry many of the original drawings and archive footage, and while we may never see the Hovertrain run again, we still have the engine's footprints to remind us how close hovercraft and train came together.